Thank you for joining us here at Simplilearn today. My name is Orion Stallard, and I'm one of the staff members here. I also am a data analyst and a project manager in primarily financial services. Currently, I'm with Bank of America in their corporate headquarters in the Southeast United States, Charlotte, North Carolina. And we're going to be talking about R, the what I would argue is probably the one of the top data science languages that you'll be able to use to get yourself launched into an exciting and rewarding career in data science. And that would be the case at whatever level it is that you're looking to aspire to, whether you want to go purely into science, if you want to use it in a business application, if you want to launch your own company. Any of those are possible with R programming. And so what we're going to do is I'm going to give you a quick background, and then we're going to do a high-level overview so that you can understand the basic functionality and be prepared to quickly use R for your own purposes, whatever those purposes are. So to begin, a little background just to give you a sense of where R came from. This is a programming language that launched in 1993. A couple of professors at the University of Auckland built this originally for their students, and it got such great feedback that that they decided to take it further and make it into an open source programming language, which R continues to be. So open source means that unlike some of the other languages out there, this is something that you can access for free, and with a resource such as Simplilearn and some of the other free online resources that I'm going to talk to you about, you'll be able to get all of the information that you need for very inexpensive way, let's say. So the beauty of R also is, in my opinion, you don't need a degree in computer science to understand. You don't need 4 years of programming to understand. You can, by the end of this lesson, you'll be able to jump in with both feet and start doing things, writing basic programs in R. So with that, this is a brief, again, high-level walkthrough, and we're going to start with these are the things that you'll know by the time we're done here in just a few minutes. The 4 types of operators, the different types of conditional statements, the loops that are used in R, commands that you can use to run R scripts, and commonly used R functions. R is what you would call, if you are a computer programming background person, if you've been working in Java, or if you've been working in Python or any of the other languages out there, C+, you've probably heard of what's called a Turing complete language, which is a classic definition of what a computer language is to be a complete language, and R meets that definition. And therefore, a lot of the things, if you do have a background in computer science, will come very quickly because they're things that you've seen elsewhere. So R has many operators that you can use to do math and logical operations. And the overview of those are arithmetic or mathematic operators, logical or Boolean, relational operators, and assignment operators. And we'll take a quick look at all those things. But just know that let's say you wanted to launch a business today, and you've just set up your cloud service in Amazon Web Service, and you're looking for a language that you're going to be able to quickly assimilate a complex data set. R is going to be a fantastic choice, and that's why Amazon has R as part of its suite of products that you can actually access in the cloud and scale up at whatever level your business grows, however quickly your business grows. So it's a pretty exciting thing that you can couple together with other exciting technology that's out there. The arithmetic operators are, you've done them since 3rd grade. These are mathematical operators such as plus, minus, multiply, divide. Multiplication, of course, is the asterisk. And for exponent, we use the caret. That's very commonly used throughout all walks of science. Couple things that you may not have seen are for division with a remainder, we use the modulus, which is 2 percentage signs, and for integer division, we use the forward slash with between the percentage signs. So if you're going to divide evenly with simply integers, you would use this. If you're going to divide and have a remainder, you use the 2 percentage signs there. The comparisons in our relational operators, greater than, less than, these are things that you should be very familiar with. A couple of differences in R that are specific to R are the less than or equal to is a less than sign with an equal to following it, and the reverse of that for greater than or equal to. And more specifically, something that's unique to R is the equals is actually 2 equal signs, and not equal is the exclamation point followed by an equal sign. So those are a couple of things that would be worth keeping in mind. Additional logical operators, logical not, of course, again, is an exclamation point. Also, R, as in other languages, Python, I believe, element-wise is how the most basic data point in R is an element. It's referred to as an element, so a single character or number. And when you want to use a logical and, the ampersand would be used individually to compare one element with another. If you're going to compare larger sets, as in vectors, matrices, and so on, which we'll get into in another lesson, then you would use 2 ampersands. And the same convention follows with the or. So and element-wise is a single ampersand, 2 ampersands is comparing vectors, matrices, arrays, and so on. The same thing would be the case for an or, where you have a pipe, or also known as a vertibar, for the element-wise or, and for set-wise you have 2 pipes. Assignment. What does that mean? In R, instead of using an equals sign, R uses specifically a less than followed by a dash to assign variables in, whether they be numeric, character, factors, what have you. This is something that's unique to R. Again, in R specifically, you can use a less than sign followed by a dash to, in this case, assign the number 18 to the variable which we have called age. So, and we talk here about left and right assignment. Technically, you can reverse this configuration and do the same thing, although this would be considered poor style by our style guides. If you want to know what is good form or good programming style in R, and that's something that's very important to you and you'd like to know more about it, Google has published a comprehensive style guide, which you can do a quick Google search and pull that up online. As with all other programming languages, R supports conditional if and nested if statements. If else allows you to test a condition and execute a command or a block of code if that condition is true, and of course execute an alternative command or block of code if that condition is false. The nested if allows us to string that process so that you can have a range of options. If your tested condition is false, then it defaults to the next condition, and so on. So the conditional statements in R. We're going to use a quick example here, and I'm going to put this in a bigger context of your business. If you're, again, going into Amazon Web Service and you have the next Uber or the next Google, and you're scaling up and you're looking to understand your client base, for instance, you may want to go through and catalog the ages and then do some analysis on the ages of your core client base. In this case, we're going to assign the number 20 to the age variable that we're describing. And then we're going to use an if statement. The if statement says if the age is greater than 18, then we're going to print a major. And for our business model that we're launching, you could even insert payday, major payday, if age is greater than 18. Else, print minor. So in this case, R is going to, once I execute the this assignment and then I execute this if statement, if I then type the word age and run, what will happen is it's going to print major. If I go back and assign age 17, it's going to print minor. And that's the basic functionality of the if-else statement in all languages, and that's kind of how it works. And this gives you the actual syntactical structure of how this is going to look when you execute a block of code in R, simple block of code. The nested if does the same thing. It just gives you an additional option, and you can actually string nested ifs together in really probably as many of those as you want, although that's not something, again, that's advised in the style guide. But in this case, x gets, this is referred to as gets 0. If x is less than 0, you're going to say negative number. Else x is greater than 0, you're going to print a positive number. Else, print 0. So this is now giving you a range of 3 choices depending upon the input that you give R in this if nested if statement. And it's going to either print negative number, positive number, or 0 depending upon the value that you come back with. Here's another way that you can use an if-else statement, which is a vectorized form. In this case, what we've done is we've assigned this variable a combination of these numerics, 1, 2, 3, and 4. That's what the C says, is to combine these numbers, 1, 2, 3, and 4. We then use an if-else, and we divide a by 2, and this little command here says if a divided by 2 is exactly equal to 0, then you're going to print even, else print odd. So here, this, when we run it, it's going to take 1 divided by 2 and calculate if it's 0. 2 divided by 2, calculate, and it's going to print out these results. So it's going to print out odd, even, basically, is what you're looking at. And you can see how if you take that and add that into your toolbox of language programming that you have available in R, you're going to quickly be able to use this in the context of a business or a scientific application that's of interest to you. Another option that R gives you that works kind of like an if statement, very similar, is the switch function. And we're going to get more into functions here in a few minutes, but the switch function is a way to give you what we refer to as a controlled branch of if-else statements. So in this case, the switch has the number 2. 2 is a reference to the position within the variables that you have in the function. So in this case, we would, with the number 2, we would end up printing ball. In the second example, color equals green. So anytime we have green, we're going to print the word avocado. Conversely, if we have the word red, we'll end up printing apple. So again, this function, switch function, as an alternative if-else controlled branch, allows you to begin to have some framework and to be able to program in it, in it quickly, program in a direction that's of interest to you. In the same way, R supports loops, and by the same way, I mean the same as you would expect in any other language such as Python, C, Java, so on. Um, the loops are for loop, while loop, and repeat loop, and we've got three basic examples of those here. In this case, for the for loop, what we've done is we've assigned this variable, vec, V-E-C, gets 1 through 5. And you'll see in a minute, we can actually just take 1 and then follow that by a colon and the number 5. That would shorten this up, but here we've expanded it out so that it's very clear what we're doing. With the for loop command that we have here, for val in vec print val, what this is going to do is it's going to print out 1, 2, 3, 4, 5. In other words, those are the values in the loop, and when it's done, the loop is complete and has finished executing. The while loop is the same as the for loop, but in this case, it's going to print whatever numbers that are encountered in the line while the condition is true. So while I is less than 6, R is going to print the numbers that it encounters. In this case, what we've done is we've set it up that I equals 1, and the while loop says that while I is less than 6, print I equals I plus 1. So in the same way that the for loop executed, this is going to print 1 through 5 and then stop. The repeat loop requires that we insert this break function, or else it will continue to go perpetually. So in this case, this works the same as the while loop. Repeat, print x equals x plus 1, so that's the same as the I plus 1. And then if we did not add in this little clause here, it would just continue to repeat. So we have to insert the break function, and that's what this is describing. Inside the loop, the break function stops the iteration, and it forces the flow to jump off of the loop. A next statement allows us to skip a value. So within a loop, if there's a value that you want the loop to exclude or ignore, then you can use the next function. So in this case, 1 through 5 again, for values in number, if it's equal to 3, next. So this is going to print 1, 2, 4, 5 in the loop. Okay, the scan function is one way that you can access documents or scripts, which is what we call blocks of code in R, and read that information into R for data manipulation. And we'll talk in another lesson about the types of data that R can read. But quickly, what we need to understand here is that scan can be used on, for instance, the file path in this case is a web URL. It can be used on any, it can be used as a file path within your own directory, your home directory. And scan is one way of reading, again, data, whether it be a script or a block of text or an Excel or a CSV. I tend to use read rather than scan, and that just seems to work for me best. Read.csv, and then followed by a parentheses, and the file path works equivalent. You can also use the source function, which will allow you to, if you put the path inside the parentheses here, that will allow you to execute a script at the time that you run this function. So you can say source, put a file path in these parentheses, and a script will execute. And here's an example of how this reads. If you're really into running things in the from a command prompt, then R command batch may be a good option for you. You can pass command line arguments to scripts. You can get very creative with batch scripting using the R command batch function. And these are a bunch more functions, just to give you a taste. And the nice thing is these are not code items that you have to go and reinvent. They're already there for you. You just have to use the built-in functions in R, such as help, to understand how they work and what the key parameters and variables are that are required for each function to execute properly. So I'll go through a couple of them here. We're not going to go through all of them, but there's a couple of them that are nice. Length, for instance, will return the length of an object. So if you have a variable or if you have a matrix, then you can put that information in the parentheses. Length will give you the number of characters. Identical tests, whether two objects are equal. That would be nice, for instance, if you had two data sets and they had varying weights, for instance, weighted averages. You could potentially use this function to make a comparison there. List of objects, that's very similar to something that you would use if you're into using command prompt programming. And append, actually the first one here, append, adds elements to a vector. The vector, which we talk about again in another lesson, is the most basic data set in R. It's a group of same elements. So for instance, they're all numbers or they're all factors, i.e. strings, character strings, and or logicals. They're all logicals. They must be all of the same data type, and it is a one-dimensional data set. So if I had 5 of my best friends' names, John, Sally, Joe, Bill, George, I could save as an element, and then if I forgot that I left Jill out of that set, I can use the append function to add Jill to my vector quickly and cleanly. These are some other functions. Again, there is a ton of functions in R, and I would encourage you to get your feet into R as quickly as you can and experiment and play with these functions. The quicker you do, the quicker you come up to speed with what they are and how they work, and there's a lot of ways that you'll be helped by using the help function that's built into R to quickly understand it. So to lower, this will take a whole string of characters and put it, take it to lowercase or uppercase. grep, as you I'm sure are familiar with other languages or may not be, but this allows us to search for patterns. And summary, this is great. Statistical function allows you to get kind of the core statistical data and pull it out of a data set, and so on. Oh, class, this tells you the class of the type of element that you're looking at or object that you're looking at.